Hello, everyone. Very nice to be here today. I'm very excited to start a new workshop on time series. We had the time series workshop a couple of years ago. I think it was in person in San Jose. Since then, I myself did not give any workshop on time series. So I'm thinking to have a couple of sessions on time series. I don't think it's going to be possible to finish time series in one session. Today is going to be just an introduction and then how we can manipulate the data sets. So we're just going to look at how we can capture the trend and then maybe simply detrend the data set if we can. So these are the things we are going to look at. So we're going to spend some time on actually cleaning the data set, slicing the data set, getting ready for analyzing the data set, right? So what do you need for this workshop? So you need some familiarity with Python, of course. I'm going to share with you the link to the Google Drive where you can download 3 files. Let me first share my LinkedIn account. If you want to connect with me, I'll be glad to connect with you. And then this is the, I'm just going to share the link to, what is it? File. Just 1 second, please. Okay. And then this is the link to the file today, folder actually today. So you can download the contents, just 3 files. And then I will also add a PDF file later on, which is composed of slides. Today, I'm not going to use any slides. I'm just going to use coding. Okay. So, but I have slides too. And then I'm also going to list the resources I used to form those slides. I already have the slides, but I'm waiting to finish this first session and then I'm going to share it with you as I'm still updating. Okay. So I just sent the file. I just, oh, I didn't send it. Oh, I'm sorry. Let me copy the link. And then now you should have the link for the Google Drive, right? Sorry about that. All right. Okay. So let me share my screen quickly. And then you can also see my screen, right? All right. And let me see. Okay. I think this is fine now. So I'm giving, let me, as you download the file, which is not going to take too much of time, let me just tell you some of the problems, talk about some of the problems that we worked before with companies, which we use the time series data sets. Those of you guys who has some experience with machine learning, by the way, I'm going to assume that we are totally new into this domain. I'm just going to assume you have some familiarity with Python. That's all right? So don't worry about whether I should have some background on time series or not. So I'm going to just assume that we don't know anything about time series. So those of you who have some experience with machine learning, creating machine learning, training machine learning models, one of the things we do, right? So we get the data sets after we do some check on the data set, we divide the data set, right? Split the data set into train and test. So when we split the data set, what we do is we randomly split the data set, right? So we then randomly take 20% of the data set and then assign it to, say, test data set, and the remaining 80% to training data set. When we randomly select or pick the data points, what happens is we shuffle the data set first. We shuffle the data set first, and then we randomly split. But if you are working on a problem where the data is collected along the time, okay? So let's say you want to predict the number of sales for a certain product next month, right? And then you have this data set, historical data set that you collected for the last 3 years. Okay, so for the last 3 years, every week you recorded the number of sales for a certain product. Now your job is predicting number of sales in the next week or in the next month, right? So for this type of a problem, you cannot simply take the data set and then shuffle it, and then split it into test and train. Because the moment you do that, you are losing the time dimension. So again, without knowing anything about time series, right? It doesn't make sense to shuffle the data set because last week's sales is related to the week before last week, right? So something, maybe the prices increased, or the weather is very hot, or the weather is very cold. Something has happened, so people stop buying, or people began to purchase. It's Christmas time, people are buying more. So time is very important, that you cannot simply shuffle the data set and then mix the data points, losing the time dimension. You cannot do that. Another example. So these are problems that we worked before. Let's say you want to create an application for the Bay Area, okay, San Francisco specifically, where ride-sharing drivers, let's say Uber drivers, right? So there are companies who have Uber fleets, right? Let's say you want to create an application for them, and this application, on top of what Uber is providing, on top of that, this application is going to give some hints to drivers from which point in the next 15 or 30 minutes there is going to be a request, okay, for a ride. In other words, from where you are expecting to have a customer in the next 30 minutes based on where you are now, so that you can drive there in the next 30 minutes. Again, for this type of an application, if you want to develop this type of an application, you have to consider what happened 30 minutes before, what happened 1 hour before, what happened 1.5 hours before. You cannot simply take the data of past 6 months and shuffle it, right? So maybe what you have to do is train a model. And I'm sorry, there is some noise outside, and then it's going to be ending soon, hopefully. Okay, sorry about that. So maybe what you're gonna do is you're going to use 1 month of data from past, train a model, and then test that model in the next 1 month. Okay, and then you shift the window. Now use the next 1 month's data, retrain the model, and test it for the next month. So imagine that there is a window where you are shifting, and that window, wherever it is actually covering the training data set. And there is another window next to that window, attached to that, which is covering the test data set. And then you just shift this window to the right. Right is future, right? So these type of problems require an understanding of time series data sets, right? So you can use many different techniques. So there are so many different techniques that you can use. You can create your own model. You can use statistical distributions, if you like. Or you can use some very well-established time series models. So I'm planning to talk about those well-established models, hopefully, in the next, maybe starting from the 3rd session. Okay, so this is a brief introduction to why we are studying time series. Most of the problems, the moment they have time dimension, which most of them do, we are going to work on a time series data set, right? And then we have to be careful about the time. So now let's begin with loading the data. Again, I'm assuming you don't know anything time series. Explore data sets, slice them, and then plot them, and then try to figure out how the data is changing by time, right? So we are going to spend some time on data manipulation today. And if you have any questions, please feel free to post your questions to Q&A, because in the chat there might be a lot of things that I might miss. So there are so many messages posted on the chat, I might miss your question. So if you have any questions, please post. Oh, so there is one question Laura is asking, when the project implementation is going to continue. So remember, we had another workshop on end-to-end machine learning pipeline. They are going to continue with that. We started, it was the 1st session. We are going to continue with that. Okay, Laura. So please wait. We are going to let you know when the 2nd session is going to be at. So I was away for a while, so that's why we couldn't continue with the 2nd session. Yeah, please ask your questions on the Q&A so I can see your questions. All right. So if you are ready, let's now begin with importing our data set. Now you have 2 data sets. I'm going to first work on the indicator data set. So this is a data set where we collected some indicators on countries. Not we. Actually, you can get this data set. This is publicly available. But we are going to world indicator data set. We are going to work on this data set now. So let's import this data set first. Okay, data. And again, the best thing to learn is practicing. If you want to learn machine learning, time series, you have to practice. You have to write the code. When you write the code, you're going to see that things that when you read, you assume that you understand and you know, you're going to see that there are a lot of gaps. Okay, so as you type the code and run it, you will see those gaps. Okay, so let me first run this first cell, which we are importing pandas and NumPy and matplotlib. So these are the three main libraries that I'll be using. And let me import the data set now. So I will import a CSV data set, CSV extension data set. So this is the data set I'll be importing, WDI data.csv. Okay, so that is my data. So let's check the column names of this data first. I mean, we can check the shape of the data set, right? So I have 65 columns, and what is that? 377,000 records, right? So 377 data points in this data set. Let me just check the columns. I'm just curious, what are the columns? What is this data set about? So as you see, I have the country name, the country code, a code for the country. So there are so many indicators that this data is collected about, and each indicator has its own code because indicator names are long, you will see that. And these are the years for which data is collected for those indicators. And you will see soon that a lot of countries are missing data for many dates, many years for many indicators, okay? So we're not going to work on all the indicators, of course not. So we're going to pick 2 indicators among many, and then we're going to focus on that. Okay, let's also see how the data looks like. Okay, so data, let's see the first 5. So this is the country name starting from A, the country code. These are the, as you see, indicator names are really long. These are the indicator codes. I don't know if you guys had any work done on time series data sets, panel data sets. If you worked on any publicly available data sets on indicators or on companies, I did that before. So you will be dealing with a lot of codes. Okay, and as you see, for this country, for this indicator, for those years or for many years, we don't have any data, and for some countries we have data. So we have to first of all see that, right? We observe that there are some missing values, a lot of missing values actually. Okay, so we already checked the number of rows and columns for this data set. So let's let's check how many indicators we have. Okay, how many unique indicators we have. I'm just going to say data and then indicator name, right? And then I'm just curious how many indicators I have. So I have 1,429 indicators, a lot of indicators, right? A lot of indicators that we collected. So let's also see how many different countries I have. Okay, so data, so country code, right? And then number of units. Okay, so I have 264 countries in this data set. I'm just curious if 264 times 1429, if that is equal to the number of rows, if there is anything missing here, if there is something that the data which is not for a country, right? It might be there. So 377, 256, 377, 2. Okay, that means for each country, I have all the indicators listed here. I might have some missing values, but for each country, I have all the indicators listed in this data set. Okay, good. So this is a well-organized data set. Okay, what I'm going to do next is I'm going to create a new data frame where I'm going to take a slice from this big data set, a large data set, let's call it large data set. I'm only going to focus on government debt as a total percentage of GDP, and also military expenditure as a percentage of total GDP, all right? So first of all, I have how many? 1,429 indicators. I have 1,429 indicators. And if somebody tells you, can you please just slice or filter central government debt from this data set? I mean, you need to, or can you get can you just get what is that? Government debt as a percentage of GDP. Okay, somebody asks you to do this job, right? So one of the things is you need to know the exact name of the indicator to be able to do that, all right? So if you don't know the exact name, then it's gonna be very difficult. There are 1,429 indicators. How are you going to find which one is what you're looking for, right? So you need to have these skills where pick one column, let's say indicator name, and then inside that column, you might be looking for a part of a string, which is matching with what you're looking for. These are things not directly related to time series, but skills that we need to have. Otherwise, our job is going to be really, really difficult. Okay, so I can give you the type the code very quickly if you like. So let me do this for you, and then I'll just go back to time series one more time. Let's say this is the string that I'm looking for. Somebody told me, can you find the government debt as a percentage of total, as a percentage of GDP? So what I'm going to look for is government debt, because I don't know the exact name of the indicator. Okay, so what I'm going to do is I'm going to take my data. This is my data. And I'm going to focus on the indicator name, right? And of course, you need to be specific about the names. Okay, so I got the indicator name. I'm focusing on the indicator name. And I don't know, this is I need to turn it into a string, and this string should contain, right? So there are different ways of doing this, by the way. There might be different ways of doing this. This string is going to contain this substring. Okay, this substring, sub1. Yeah, I think I did this correctly. Let me run this. Yeah, so I got, as you see, I got the records where it is including in the indicator name, it is including government debt. So there are some of them government debt total GDP. There are some current LCU total GDP. So this is what I'm looking for. This is what I'm looking for. So you can do the same thing for military expenditure. Maybe there are some other indicators for military expenditure. So you can do the same thing. Let me just get rid of the results, so without printing them on the screen. So it takes a lot of space. All right. Now let's do what we were supposed to do. I'm just going to create two data frames, one for government debt, the other one for military expenditure. So let's do it together. Let me see, there are some. Why is there an unnamed 64? Where is unnamed 64, Charles? I didn't get unnamed. Oh, I don't know what this column is, Charles. So I don't have any idea what this column. I was wondering when part 2 of the data science project will take place. Oh, yeah, Laura, that I answered that question. Okay, so let's continue. Let's create the data frames for these two indicators. So central government, let me call this central government debt. Okay, so this is one slice that I'm going to take from my data set. So this is my data, okay? So I'm going to select a certain, what is that, indicator. So from my data, indicator name, right, is supposed to be equal to, right, supposed to be equal to this central government. I'm just going to copy this. You can, that's why I put it here, so you don't have to type it. It's a little bit long. Okay, so I'm looking for the data points, the rows actually, where indicator name is central government debt, total of GDP. Okay, I think I need to put one more. Okay, so this is central government. Yeah. Okay. All right. So let's do the same thing for military expenditure. Military expenditure. Again, data. Again, what? data is military expenditure. Just copy this. It has to be the exact this name. Measure data, log data, indicator name is this. Okay, so I got the central government and military expenditures. So I have two frames. Now let's check the shapes of these two frames, central government debt. Yeah. So I have 264 countries and then 65 data points. Same thing for the other one, expenditure. Yeah, the same thing. All right. So I got 264 data points and then 65. So, well, you can just slice from central government debt. So there are 65 columns. As you remember, I have columns for different years. So I can simply slice that take a slice for the year 2010. So we can do that. So this is what we're going to do in a moment. Okay, in a moment. All right. Another thing, yeah, let's slice it and then get the description of that, just to demonstrate it. Central government debt. Okay, so from central government debt, I'm going to just take 2010. Okay, well, if you like, you can just get the description for this slide. Central departments, right? Okay, so I have 60 not null data points, right? That's what it means. And this is the mean of that for 2010 across different countries, 264 countries. And what is it? And these are the interquartiles. These are quartiles, actually, 25th, 15, and 17th. Okay, so let's continue. What I'm going to do is now I'm going to put these two together. Okay, I'm going to put these two together, these two data frames together. So for that, I'm going to use country codes as the index. So it's going to be very helpful if I assign country codes as the index of my data frames so that I can use country codes to concatenate data sets. That's what I'm going to do. What I'm going to do is I'm going to take central government debt data sets, okay? And then I'm going to change its index. Right now, let's see index. As you see, right now, the index is composed of numbers. When I first took the data set came with indices assigned to each row. So I still carry those indices. So those indices are uniquely referring to a certain row. What I want to do is I want to change these indices to country codes so that I can refer to each row as using the country code. So that's what I'm going to do. I'm going to central government debt. Okay, I will use country code. Okay. All right. Now let's see the index. We just checked the index earlier, right? So let's see the index again. Now you see, instead of using numbers, I'm using these country codes, which is going to be very helpful to see what row corresponds to which country, right? It's going to be extremely useful. So let me do the same thing for military expenditure. And then later I can use these indices to put data together. So let's see, this is military expenditure. Expenditure and military expenditure. Okay, so I changed the indices and then I'm checking if we have any questions from time to time. Are you going to share the script after? Yeah, I always, after I'm done, I always put this file into the folder that I shared with you, Judy. So you will have this file. Sure. Yeah. So same approach for stock data sets. Yeah. So it's one of the most difficult problems. So I wish one of you guys, one of us can solve this stock data set problem and then share the solution with only this group so that we can collectively be really, really wealthy. Okay, so brackets, so thank you, Jeffrey. And then why are we creating two data frames? So we don't need to create two separate data frames. At this point, we're just making some exercise. If you like, you can just, you could have selected those two columns simultaneously. And then assign the country code as the index of this data frame with two columns. You could do that. So this is just an exercise. Okay, it's an exercise. All right. Now what I'm going to do is I'm going to select, as I did earlier, I'm going to select government debt for 2010. I'm just only going to select 2010 records for government debt as well as 2010 records for the military expenditure. That's what I'm going to do. So let me just take one slice from this. Right now, this central government debt has 65 columns. Right? I'm just going to take one of these columns. That's what I'm going to do. So central government debt 2010. Okay. So central government debt. I'm just going to take the slice 2010. Okay. And so let's do it. Let's go this way first. Central government. Central T. Okay. So let's do this first, and then I just want to check one thing. So let me take this. Okay. So check the shape. Now I have 264 records. Remember, 264 countries. This is the central government debt for each country for year 2010. But I'm not sure if each country has a record for 2010, right? So maybe you can check this by, I mean, maybe we can do this. Right? So there are some countries having, as you see right now, what I see is, I mean, the first 5 and the last 5 have all records for 2010, but I'm not sure if all of them. So as you see, there are 204 of the countries out of 264 have records for 2010, and then we have 60 missing values. So what I'm going to do is when I am selecting, when I am filtering my central government debt data frame for 2010, what I'm going to do is I will only select the ones which are which have a value, okay, which are not null. So again, there are different ways of doing this. So first of all, this is that column which has 2010 numbers, the numbers for the year 2010, and out of these, I'm just going to exclude the ones which are null. Okay. Yeah. I'm exactly running this, and then only selecting the ones which are not null. Now let's see. As you see, there isn't any which has actually earlier I said there are 60 null values. Actually, there were 204 null values and 60 non-null values. I selected only the non-null values. So right now, the shape of my data set is only 60. I only have data for the year 2010 only for 60 countries. Okay, earlier I said the other way. I'm sorry, so I'm correcting myself. Okay, let's do the same thing for military expenditures. Okay, so I don't want to copy it. I want to have this with you. So it's going to be an exercise for us. Military expenditure 2010. Okay, so what I'm going to do is I'm going to first take my military expenditure data frame. And then from that data frame, I'm going to select the column 2010. Okay, and then from this column, I will only select the ones, okay, select the ones which are not null. Okay, now I'm just going to copy this. Again, the goal is doing practice together. Okay, all right. Okay, now if you are curious, what is the shape of this new data frame after excluding the, I only have 193 countries which have a value for 2010. Okay, now let's put these together. Let's put these together. Let's put these two columns together. So what I'm going to do is I'm going to call this new data frame as data to plot, because I'm going to plot this data set. Okay, and what I'm going to do is I'm going to concatenate, okay, these two data frames. So the first one is central government debt 2010, comma, the other one is military expenditure 2000. Now, just keep in mind that central government debt may have a value for a country, and military expenditure may not have the value for the same country. So we still may have missing values when I concatenate these two data frames. So let's see how it's going to look like. Okay, so I put these two data frames together, and this is happening in the so I'm putting two columns together, not I mean the two sets of rows. I'm putting two columns together. Okay, now let me see how the data set looks like. Data to plot. Okay, so this is how the data set looks like, the first 5 records. So these are the countries. As you see, it says 2010 2010 because that's how our military, so that's how the data sets will look like. So this is 193 is for year 2010, right? So I'm just going to now rename these two columns accordingly. So the first one is government debt, the other one is military expenditure. So let's do it together. So what I'm going to do is I'm going to say data to plot.columns is, I'm just going to say the first column is central government debt, okay, and the second one is military expenditure. Perfect. Okay, now if you like, you can check this one more time. I don't want to run it there one more time because I want to see the difference. Yeah, now I have the column names nicely. Okay, so now what I'm curious about is if there are any observations here where a country has a value for one of these columns and not for the other one. So actually, data to plots. We just look at the first 5 and last 5 records. As you see, on the last 5 records, I have some countries where I don't have the government debt information. All right. So what I'm going to do is I want to eliminate any observation which has at least one null value. That's what I want to do, okay? So how can I do that? I want to eliminate at each row which has at least one null value. So I want to have only the rows which have both columns with a valid value, okay? So what I'm going to do is, again, similar thing. I'm going to do the similar thing, data to plot. This is my data set, right? So I will only select the data points. Let me, before writing this, let's go step by step, okay? So data to plot. Sometimes we assume we know things, but let's go step by step. I think it's going to be much better to us to know what's going on. So this is giving me, data to plot is null, is giving me if any of the cells in this table, let's call it a table, has any missing value. Whenever we see true, that means there is a missing value. And we just observe that there is a missing value. Okay, is null. Now, if I add this following function, any, along the axis 1, Okay, so let's see now. So this means if any of the rows, for each row, if any of the columns has a missing value, I'm going to have a true Boolean value. Okay, so the first column, the first row, as you see, doesn't have any missing value, so it is false. The last 5 ones, they have at least one of them false, so that's why we have one of them null. That's why we have the true value for this. Now, what I'm going to do is I'm going to select this, and I want to eliminate these true ones. So that's why I'm going to negate it and then put this. So when I do this, I am actually, let's call this t equals. So now let's see. Data to what shape versus d dot shape. Okay. So as you see, from 205 data points, I'm reduced to 48 data points. I have only 48 countries where I have data for both columns for year 2010. That's what it means. Okay. I know this is very general. It's not time series, but we're slowly getting into time series. Okay. But we need to learn, we need to know how to manipulate data set before we even talk about data series and time series. I'm sorry. So we need to know, have these skills. Okay. All right. Let's now try to create a histogram. Okay, histogram of one of the columns. Okay, so what I'm going to do is I'm going to say, I'm going to pick PLT. What is PLT? PLT we already imported, right? PLT is the pie plot, which is going to help us plot figures. Okay, so PLT dot histogram. So histogram is going to give us the frequency of in our data set. So let's see. So this is the first 10 data points, and let's say this is the military expenditure. So what we're going to do is we are going to divide this. These are like floating numbers. We're going to divide the range of these numbers into bins, and then I'm going to assign these values to the corresponding bins. Let's say there is one bin between, let's say, 2 and 3. So these two guys are going to be within that bin. So what I'm going to do is I'm going to put these countries into bins with respect to their, in this case, military expenditure. I'm just curious, how many of the countries have military expenditure within the range of 2 and 3? How many of them have within the range of 5 and 6? So that's what I'm going to plot in here when I use histogram. So from histogram, I'm going to say, let's use the D, okay, and military expenditure. Military expenditure. So as you said, this is just giving me the frequency of countries whose military expenditure is falling in one of these bins. All right. Okay. All right. Let's continue. Now I'm ready to get into a little bit about talk about time series. Okay, so let's now talk about time series data sets. I'm going to again filter the data set. Again, I'm going to take central government debt, which we created already, and military expenditure. This time I'm going to focus on country USA. Okay, and then, but this time not just 2010. I'm going to filter the data for USA, for the central government debt, as well as military expenditure. That's what I'm going to do. So let's do the first one, central government debt. Okay, and this is the US data. Okay, central government debt, which we created already. Okay, now I'm going to select only the USA one. Okay, log. Let me go to next line. All right. So central government debt, I'm just going to copy this. Sorry. To copy this. All right. And from here, I will only select the data where country code, okay, is USA. All right. So I'm going to select only central government debt data points where country code is USA. So let me run this. I want to show you something. So central government.USA. Let's see how this looks like. Oh, okay. So here is the data set. So this is USA. This is government debt as a percentage of total GDP. So there is some indicator code, and these are the years. As you see, some years have no value, missing values, and then some years have non-missing values. Okay. So I'm going to do the same thing for military expenditure. Okay, let's do it. Military expenditure, US. Again, I will type this for the sake of practice. Okay, military expenditure. So this is my data set. I'm going to select the rows where military expenditure data frame has USA for the country code. So country code is USA. Okay, so here we go. All right. So what I want to do now is, I want to put these two rows together, but I want to make 1960, 1961, 1960. I want to make these as the indices. And you see what I'm saying, right? So for 1961, for 1964, for 1965, what is the value? So I want to make the years as the indices of the rows. In other words, I'm going to take a transpose of these two data frames. So let me do the transpose here and then show you what it means. So first, let me so this is the military expenditure. So I'm going to take the transpose of this and then show you what happens. So as you see, I just took the transpose of this vector. Now it is a column vector, right? I'll do the same thing for government debt. Okay, I'll do the same thing for government debt. So that central government debt USA is also a column vector. Okay, very good. So again, these are just I'm manipulating the data so that I can work on it. All right. So what I'm going to do is now I'm going to concatenate these two data sets. I'm going to put them together. There is one column and there's another column. I'm going to put them together and form two columns of data sets. So data, let's call it data US, is, again, I already used this earlier. I'm going to concatenate these two guys. Okay. So one is military expenditure US. And the other one is central government debt US. And this is happening on column-wise. Okay, let's see if this is going to work. Yeah. Okay, now let's check data US. All right, so now I have two columns. I'm going to change the column names, by the way. And then also, I'm really interested in these numbers. So I'm interested in the years and the corresponding values for those years. I'm not interested in this country code indicator names. I want to get rid of them, which I will, okay, which I will in a minute. Okay, let's continue. Now, what I want to do is I want to give the beginning index and the ending index for me to slice from this data set. That's what I want to do. So let's see how we can create a starting index for me to slice this data set, this time row-wise. So what I want to do is, somebody told me, can you please put together the federal military expenditure and then the debt of the federal government for USA between years 1960 and 2010. Okay, that's what I'm doing, 1960 and 2010. So that means the beginning year is 1960, the end year is 2010. So the beginning index is where I'm using numpy's where method, where data .us, okay, underscore US .index. Now, for those who are new to this, again, I'm assuming that they are relatively new into this. Okay, so if you check the index, as you see, index is this column on the very left. These are the indices of each row. Okay, we are referring to each row. You can refer to each row using this index. So I am interested in index 1960. That is where I'm interested. So that's why data use.index has to be equal to 1960. Okay, so let's run this. Now, what is this index 0? It's a tuple. It's a tuple of an array which is listing the locations, the indices. So 0, 1, 2, 3, 4. So 1960 is the index 4, in other words, the fifth element of indices of this data set. All right. So again, these are some details, but without knowing this, I assure you that if you want to create a data set between 1960 and then 2010, you're going to run into these problems. Okay, so let's understand what we have in here. So what I'm going to do is, I don't need this. So I cannot slice my data using index 0. So I need this index 0. I need to get into this tuple. Okay, the first element of tuple is array. And from this array, I want to get the first element, which is 4. So that is the index of 1960 in the indices of my original data set. Okay, so that is index 0. So now I know that I need to add this 0 and 0. So that index 0 is 4. Let me run this. So I'm going to do the same thing, almost the same thing for 2010. This time, this index is the stopping index, where this is 2010. Perfect. Now I can slice my data. Again, you can do this in many different ways. Okay, you can do this in many different ways. So what I'm going to do is, I'm going to take my data sets. This time I'm using ilog because I'm using the index numbers. Okay, so remember earlier I was using log, now I'm using ilog. So it's going to start from index 0 to index 1. If I do this way, if I leave it this way, 2010 is going to be left outside, okay? Because the stopping index is not included, right? So that's why I'm going to add 1, all right? And then all these rows, for each row, all the columns I'm selecting. Okay, now this is data US. Perfect. So now let me see how data US looks like. Now, as you see, I have the data from 1960 to, what is it, 2010, and still the column names are not very good. So let's correct that one. Data US columns is, let's give some nice names: federal military expenditure. I'm going to give a break, okay? And that federal debt. Okay. Let me see. Are you going to share the script after? Yeah, I answered. Should we make a transformation to get the histogram more close to normal distribution? Dennis, later on, so later on, depending on what kind of a model you are using, you might need to make transformations to make distribution of your data look more normal. So for some cases, you don't need to make any kind of distribution. Okay, so the transformation. For now, they are not going to make any transformation because we are not going to use that histogram in our models. Can we do this data US log 2010 to 2019? You can do that, Swati. You can do that because definitely you can do that. I'm just, again, these are just exercise. So let me write what Swati is saying. And yeah, it's the very short way. As I said, there are many different ways you can do this. So if you are going to use indices themselves, so you can use this. I think it's going to work. So this is the first one. And oh, this is the 1960, 2010. So 2010 should work. Yeah, it works perfectly. So again, this is an exercise for working with indices, start and stop indices. As I said, there are so many different ways, and this is a Swati, thank you, much faster and easier way to slice our data set. Yeah, thank you. All right. Okay, let's continue. Let me run this first. And I'm just checking if there are any questions. Why don't you follow the procedure of joining columns? It avoids confusion. So you can also, Ramjan, again, you can do this in different ways. You can perfectly join two columns too. You can perfectly do that too. I don't want to do it now. I know that I'm going to have trouble with the code, so I need to try and use trial and error. But yeah, you can do that too. All right. So what I'm going to do next is I'm just going to drop the missing values. So as you see here, there are missing values, right? So let me just drop the missing values as I did earlier. So what I'm going to do is data US. If there are any missing values, I just want to drop it. Okay, so let me make this equal to this. And I don't need in place here. Okay, so let me check the shape of my data set now. I have only 22 observations where I have both columns without any null values. All right, I have only two observations where I have 22 observations without any missing values in both columns. Okay. All right, now one last thing before we get into panel data, and then I'm going to give a short break then. Let's just plot federal expenditure, military expenditure, and the debt as two separate plots, okay? So what I'm going to do is I'm going to create subplots, okay? And I will have two subplots, and then these subplots are going to share the same thing for their x-axis. And let me also, this is the figure, the total figure, which has those two subplots, and this is referring to those two figures, two subplots. AX is referring to two subplots, and F is referring to the figure itself. Okay, so can also say, I think we can say this here. I hope it's going to work. Figure size 5 by 5. Let's see. Yeah, I have two subplots. Let's continue, fill these subplots. First of all, I'm going to have the first figure. Let me take the first figure. This is the first figure. Okay, I'm going to set its title, okay, as federal military expenditure. Okay, and I'm going to do the same thing for the next figure, but let me first finish this first figure. So when you run this, as you see, this is the first figure. Now let me fill this figure. What I'm going to do is I'm going to plot federal expenditure here. So plot what I'm going to do is I'm going to select the data first. So from my data US, I will select federal military expenditure, right? That's how we named it. Federal military expenditure. Okay, this is my data that I want to plot. And then I am plotting this. So let me use this. So as you see, when you just plot it, it is plotting to the second figure. I need to tell that I'm plotting this into the first figure. So that's what I'm going to do. So what I'm going to do is AX is equals to X is 0. Okay. Now I'm plotting to the first figure. So if you like, you can even change the line style. Okay. And then let's also make this, I don't know, marker. and then color. Okay. Okay, so I got the first figure. I'll do the second one very quickly. I'm just going to copy this because now we know what is happening. I don't need to talk as I'm typing. So this is the second figure. It is the federal debt. And this one is federal debt. Okay. You can use a different marker if you like, or you can use a different color. Let's make this simple. And this is the. Okay. So what are we seeing here? Again, this is just a plot of federal expenditure for military expenditure and the debt of the government from year 1960 to, originally it was supposed to be from 1960 to 2010, but because we had a lot of missing values, those are gone, right? So that's why we have the data set from 1989, okay? So you can at least see how as military expenditure is dropping, how the federal debt is changing, as military expenditure is increasing, how the military federal debt is increasing. So you can have a sense of how these two are related to each other along the time, all right? Okay, so let me give a break here, short break here, and then I am going to this time create a cross-sectional data set, and then a time series data set, and then a panel data set. And then next, what we're going to do is we are going to use another data set to see the trend in the data set. And then we are going to use linear regression to capture the trend. And then we are going to subtract the trend from the data set to have trend eliminated, detrended data set, and then see the seasonality in the data set. And then we are going to do our best to eliminate seasonality from the data set as well. So these are the topics I'm going to talk more in the upcoming sessions, but again, this is just an introduction. So that is one thing that we're going to do. Second, if we have time left, I'm going to talk about white noise or Gaussian noise, and I will also talk about random walk, okay? And then why we are interested in that, that's what I'm going to talk about. Let me give a 10-minute break. My time is past 3, so I'll be here past 13. Okay, past 13. Thank you. Okay, hello again. I just posted the link to the drive. So if you just joined or you missed the link, you missed the link to the folder. So I just shared the link, right? Okay, let's continue. Now I want to create some data sets. For example, I want to create a data set where I'm going to have multiple individuals at one point in time, which is cross-sectional. So let's say year 2010, I have many countries in year 2010. And then we created actually together for USA, right? So a time series data set where USA military expenditure or government debt was collected, was actually stored for many time points, for many points in time. So that is time series data set. I have only one what is that indicator. For that indicator for USA, let's say government debt, I have multiple observations for one for each year, right? So that is time series data set. What also I can do is I can have a time series data set for multiple countries, right? So that's going to be a panel data set. So I have multiple countries, and then each country has multiple records for multiple data points. All right. So that's what we're going to do now. We are going to create military expenditure for the following countries between 1960 and 2010. And again, keep in mind that we might have some missing values, okay, for different countries at different years. Okay, so we're going to do very similar procedure. We're going to follow a very similar procedure. Because I'm going to have now multiple countries, so I just want to say that I is for indicator name. Okay, and then M is for military expenditure. So let me just copy it. I can also copy military expenditure is a percentage of GDP. Okay, so that I don't want to type this over and over again for multiple countries. Okay, and what else? So let's begin with creating our data set. So I'm going to do this for let's say for USA first, and then I'm just going to show you what happens, and then we're going to repeat this for the other countries. So run this first, get rid of this. Okay, so again, remember this was my data. Let's remember the data. This is our original data set that we loaded, right? So I'm going to take from this data set, okay? I'm going to take some rows from a set of rows actually, or in this case, it's only military expenditure for one country. So I'm gonna pick one row for a specific indicator. That means I'm picking just one row in this case, just one row. So what is that row? What I'm going to do is I'm going to choose if I have indicator from my indicator is equal to M. So what is I is the indicator name, M is the military expenditure as a percentage of GDP. So this is one of the conditions. So let me take this inside the parentheses and then and. Okay, that is the first thing. And I also want to pick, let me also add this C for country code, so we don't need to write it multiple times. I'm going to check if data and then country code is equal to USA. Okay, so I am going to select, so let me also put this inside the parentheses. I'm going to select the row which corresponds to indicator equals military expenditure as a percentage of GDP and country equals USA, right? So let's do this and then see if it works. And it didn't. So allocation based, blah, blah, blah. It says something about allocation, blah, blah. So what is wrong in here? What do you see as wrong in here? I need to also select right? I need to also select, so this is just these are the rows. I need to also select the columns, right? So for which columns I want this data set, right? So if I say this, what happens? Location-based Boolean indexing on an integer type is not available. So anyone who has any ideas about what is happening here? So let's just look at this one. What is this? Okay, let's just look at this one. So it is Boolean. It is a series D-type Boolean, right? So if I make this put into a parenthesis this whole thing, and then take the values. Now it's an array, right? Now it's an array. I turned that series into an array, right? So this array says, don't take the first row, don't take the second row, don't take the third row. So I'm looking for a true value here, which is going to correspond to the row that satisfies these two conditions. Okay, so let's do that. Again, there might be different ways of doing this. Easier way, please let me know. Now I have United States military expenditure, but I don't need these indicator codes. Remember, I already created index 0, index 1, index 0 to index 1 plus 1. Okay, now I got the data set for USA, right? For military expenditure in between years 1960 and 2010. Again, if you can find an easier way, please share it. Okay, thank you. All right, so let's continue. This is for USA. I'm going to repeat this for each country. So what I'm going to do is let's do this for China. Let's call it CHN. I'm just going to copy this and put it in here. Instead of USA, I'm going to say China. This is capital CHN. All right. So then I'm going to do the same thing for USA. So now let's call this USA. Okay, this is one thing. This is one thing. So let me run these two and then show you what happens here. So let's look at China, CHN. So as you see, this is the index value. And these are, remember, these are original data set. We didn't change the index into country code yet, okay? And these are the years and the corresponding values for these years. So what I want to do is, I want to take this, take only the value. So let's see. So when I do this, values, it's an array. So let's look at the shape of the values. So it is 1 by 51. I want to take the 51, what is that? I want to take the 51 values of this, okay? So let's see, values, 0. So now, instead of dealing with a two-dimensional array, I'm dealing with a single-dimensional array, and then I have all the values inside this array. So this is an array, which I put the values corresponding to China, right? So the next thing is, what I want to do is, I want to turn this into, what is that? Into a series, a pandas series. So let's say pandas series. So these are the values, and I'm going to assign the column names as indices. Okay, index is. Now, I want to show you what I'm doing here. So what is this? These are the column names. I'm going to assign these column names as indices to these values. So this value has the index of this column name. Again, you can do this in a different way, all right? And then let me know if you know a better way, so I can introduce that. Okay, so after I assign that row to China, right, CHN, what I'm going to do is, next is, I'm going to take the values, okay, and then use the columns as the indices, I'm just turning this CHN into a panda series where index values are the column names. Okay. All right. So I'll do the same thing for the other countries. Let me copy this. This is going to be USA. All right. And 2 more countries, right? So I'm going to repeat this again. So I'm just copying it. So let me make this India, IND, yeah, and this is this. This is India. Instead of CHN, I'm going to use IND. Okay, that is the code for India, and this is India. And let's do the same thing for UK. Great Britain, and then this is going to be GBR. Okay. And this is GBR. Yeah, it's taking time. Right? This is taking time. So this should be, yeah. And I have, okay. So I got all my, okay, I got all my data now ready. So one thing I didn't do is I might have some missing values. Now, be careful with this one, please. Let's pick the first data point, CHN. So as you see, for different years, for some of the years, I don't have any value, right? So if I simply eliminate these values, and I can do the same thing for the other countries, which they may have missing values for different years. If I simply eliminate these missing values, and later on, if I want to plot them all together in a single plot, right? So then, I mean, I can show you an example. Then you're going to have the plots misleading you because the missing values are gone. So 1989 is going to appear like 1960. Okay. So it's almost like this. So once others are having a lower expenditure, this country has a higher expenditure for the same year, right? So we have to make sure that when we plot for different, in this case, countries, but in general, say different products along the year axis, we have to make sure that the years are aligned, right? So that's why I'm not just going to drop the missing values, but I'm going to replace them with a value of 0. That means I'm still holding those time points. So let me go back in here. So after I define, I have the values for China and USA and the others. So what I'm going to do is I'm going to fill all missing values with 0. Okay, so that at least I can see for which years I don't have a value. So let me do this for all others. Okay, perfect. So now I'm ready to plot my figure. I'm going to plot a single figure. So let me delete this so that we don't have. I'm just deleting these. These are things that I used to demonstrate what we are doing. So what I'm going to do is I'm going to plot a figure. Okay. And let's say figure size is the same as before, 5 by 5. Okay. And in this figure, I'm going to take my data. You can use different line styles if you like. This is not so important. I'm just putting here that you have these options. Okay. So you can use marker or whatever, but let's use different colors. So let's first plot this and then see if it works. Yeah, so this works. This is USA. Now let's do the same thing for all other 3 countries. Okay, now let's put the legend too. Oh, and we got there. Okay, so we have some problems here, right? So what happened here for the data for India, and then what happened here? So we made some error here, right? So there is something that we didn't do correctly. Yeah, this one, right? And then this one. All right, so we got the data set, right? So again, please keep in mind, right? So if we had not used 0 for here, you can try this. You can try this. Actually, sort of fill now. So let me sort of fill now. Let me use drop now. That's what I mean. Okay, that's what I mean. So now we are misled because it tells us that this is the data for these years, and then we don't have any data for any year after 1980. So it is misleading. So we have to be careful. These are small mistakes, but it may have implications, right? So we may not be really aware of this. Of course, this is very simple to see that, but there might be cases that we may not be aware of the mistake. Okay, so let me change this. Okay. All right, so this is all about this section. Let me run this, and then let's continue. All right. Perfect. Now let's talk about a little bit now more. Let's get deeper into time series. Okay, so we are now slowly getting into time series. So what I'm going to do now is I'm going to use a different data set, and we are going to do similar things at first very quickly. And then we're going to see the trend. We are going to observe the trend. So here also we can see there is a trend, right? So there is a trend as the military expenditure as a percentage of GDP. So we can see so there's a trend. There's a down trend, right? So I could have plotted the government debt. I think government debt is going to show us a upward trend. So we are going to observe this trend much better with this carbon dioxide data set. It's a very well-known, publicly available data set. So we are going to do our best to eliminate this upward trend from the data set. That's what we're going to do next. Let me see if you have any questions or anything. In your code, D is the data frame without NANs. Data US looks like the data frame still with NAN, but I think earlier used in place through your data US data frame nubbles has no NANs. I just want to clarify because I was using a data frame without NAN to plot and I see many blanks. Oh, thank you. Yeah, that might be the case. So SA, that might be the case. So we need to go back and then check, but I understand where you are saying here. So earlier, let me quickly run one more time. Talk about this one. From here. I'm not sure, so I didn't follow that. So let me see here, right? So I said D, and now from D. Okay, no. Here I use military and government expenditure. Here I concatenated it. These are the indices. I think I didn't use D to form this data set. Oh, here, I see. So you said you did not drop data US, but I didn't use data US for this data set. Here I didn't use DS. But what you are saying is if you do not drop it, so instead of D, So that I understood what you mean. I understood what you mean. So yeah. So here we have missing values, so they are not shown in here. That's another thing that we were misled. You see, I made a mistake earlier, probably. So as you see, this part is corresponding to years 1960 to 1990. And then we didn't have any data for federal debt. So what we did earlier was we eliminated the missing values. I think we only saw this part. We only saw this part. We eliminated this left part. That's what happened, I think. Yeah. So there was no mistake, but we didn't see the earlier part of federal military expenditure. Yeah, this notebook is going to be Farzana. It's going to be available. I'm going to just move this to the folder that I shared with you. How we do statistical calculation for missing and like average. So when you take the average, Michael, the missing values are going to be disregarded. So they're not going to take them into account. Let's say you have 10 data points, 5 of them are missing. You will take the average of only 5 data points. Okay. Yeah, let's continue. Thank you for the questions and clarifications. I appreciate that. Okay, let's read this data set. This time our data set is an Excel file. So for those, so let me first type this and then let's call this data 2. Data 2, so that we're not going to mix with the earlier data. So if you don't have read Excel, so you might have an error. So let's first run this. If you have an error, let me know. Okay. Monthly CO2 information. This is an Excel file. Okay. And then let me first run this and then see what happens. Now, yeah. No such file. Monthly, monthly, let me see what it is. Monthly CO2 concentrations. Okay. Now you can run this if you have any problem like read Excel is not defined. So then you need to install it. Okay. Let me type this here. Pip install open high Excel. So you need to run this install. Okay, if you have an error saying that you don't have read Excel method. Okay, all right. So what I'm going to do is, in addition to loading the data set, I'm going to convert. So let me show you this. Again, I'm doing my best to go step by step, so that I'm not going to make any assumptions that we know this or that. Okay. So this is my data set. I have year and month. As you see, right now they are not integers, right? So they're floating numbers. They're not integers. I want to get rid of these dot zeros. So that's what I want to do. I'm going to convert. I'm going to define a converter dictionary. So this dictionary is going to convert year. Again, there are different ways of doing this into integer. And similarly, it's going to convert month into integer. Okay, let's run this. And it gave an error, converters. This is converter. It says equals. Should be equal. All right, now let's see. As you see, my year and month are integers. Okay, next, let's check the shape of the data set. Let's check the data set, shape of the data set, data 2. So I have 174 data points. Now, this data set is much smaller than the previous one. Let's eliminate any missing values as we did before. So my data is, so as earlier, again, because we already did this, I will be very quick on this one. Any missing value in any of the columns, eliminate that row. Okay, that is what it means. Okay, now let's check the data. So some of the data, some of the rows are eliminated, not many. not many, but some of them eliminated. Okay, perfect. Now, what I want to do is, I want to sort my data based on year and month. Okay, so let's do it. Data, sort values. Okay, so that I'm going to have a nice year and month sorted data set, so I can plot it later. Okay, I don't want a year coming before, like I don't want 1970 coming before 1960. Okay, so year. Okay, and then month. I mean, when you have more and more columns and rows and different data sets that you need to merge, believe me, time series data set becomes really, really messy. Okay, dealing with time series data sets becomes really messy. All right. Okay, so I sorted my data, right? Now let's see if we can observe any trend in my data set, right? Any trend in my data set. So for that, what I'm going to do is I'm going to take my data. Okay, again, remember, this is my data. I have carbon dioxide measurements. This is the year, and this is the month. That's my data. For now, when I plot it, I'm not going to see year and month appearing on the x-axis. Instead, I'm going to see these indices. Okay, let's do it. Data 2. So don't be confused the first time when you plot your data if you don't see year and month. Okay, so let's plot this. Color. Okay, here is my data set. Again, as you see, these are the indices. As of now, they don't mean too much. There are, I actually, before this workshop, I compiled the code for printing the years, the months, and then underneath printing the year. I have that, but typing this is going to be very confusing. I didn't want to do that. Okay, so I have the data set, and there is a very clear visual. Visually, we can easily see that the data is upwarding, right? So there's an upward trend. The trend is upward. All right. So this is one of the major things, components of a time series data set. In addition to time being the dimension, so the trend is one of the things that we are going to focus on when we deal with time series data sets. All right. So what I'm gonna do next is I'm gonna do a little bit. By the way, before getting into dealing with this trend, I want to show you one thing. So sometimes, if we don't look at the data in the long run, like here, right? So from year, what is the year? So from year 1974 to, I don't know, all the way to, I don't know what year. So maybe 1990, right? So long run, so I can see this trend. But if you look at only a part of your data set, like if you zoom in, you may not see this trend. So you can observe the trend if you look at the long run. Okay, when you check the data in the long run, you can observe the trend. So let's see how this can be misleading. It can be misleading when we zoom in. Okay, let's see. I'm going to this time take my, let's make it simple, data 2, CO2. Okay, I'm still plotting CO2, but this time I will choose, okay, a certain year. So data 2, year is between 1980. Let me make this. Okay. Somehow each condition is supposed to be inside brackets, parentheses. Okay, data 2 and year is 1981. Right. So let's plot this. Letter. Yeah. Okay. Nothing. 1980. 1981. So is there anything wrong? Can you see anything wrong in here? Oh, it is empty. How come it is empty? Oh, it cannot be and, right? It should be or, right? It's either 80 or 81. Or if you say and, there is no such data, right? Both 80 and 81. Yeah, very silly mistake. Okay. So let's change this with or. And then have it as. So as you see, there is no obvious trend in here. So this is one of the mistakes. Again, this is a very simple case. One of the mistakes that we might make when we deal with time series data sets. So you need to zoom out and then look at the long run to see the trend. If you zoom in, you may observe maybe seasonality or cycles. For cycles too, we need to long shot. But if you just zoom in and focus on short duration, we may not see the trend in the data set. And trend may not be so much of a problem, actually, if it's a problem, if you just zoom in the data set. Okay, so now let's fit the trend line and then see what we can do with that fitting trend line. So what I'm going to do next is I'm going to import scikit-learn linear regression, okay? Linear regression. So I'm going to basically, okay, here is the thing. Those who are coming from machine learning background, right? So what we do is we have the target variable and we have the features, right? So target variable is what we want to predict. Features might be multiple variables that we are taking into account, right? So in this case, our case is very simple. Our feature is time, okay? So our feature is time and our target variable in this case is carbon dioxide measurements, right? So given time, what is the carbon dioxide management? So measurement. So that is what we are predicting in this case, okay? The linear regression model is going to use time as the feature and carbon monoxide measurement in this case as the target variable, right? Okay, so let me instantiate my model. Okay, this is one instance of linear regression. So what I'm going to do is I'm going to take my model and fit, okay, on my data set. Now, so these are things that other times we are getting confused. By the way, if you have any suggestions, any questions, please let me know. Do we need to zoom out to see seasonality? So for seasonality, okay, we are going to come back to seasonality. We are going to not come back. We're going to talk about seasonality. Here, I mean, I can see that 1980, 1981, and then for 4 quarters, actually, these are monthly measurements. I can see that for some months, the measurements are, the amount is increasing and then decreasing. And again, most likely for the same months. So I can see that. So it makes me think that there is a seasonality here. But even for that, I need to zoom out because this might be happening only for these 2 years. If I want to have a general idea about data having seasonality, I still need to observe this on many years, okay? We are going to come back to seasonality after we address this trend on the data set. What I was going to say, so when you use linear regression models, again, now I'm going back to machine learning, but when you use linear regression models, your feature set, scikit-learn, is expecting a 2-dimensional feature set, okay, 2-dimensional. So remember, what is your feature in the time series data set? The time. So let's check the time data. Look, this is my data. This is my data. So in this case, of course, this is time, but I need to define this time. Right now, it is not time, it's just numbers. So what I'm going to do is I'm going to use this index as the time. Okay, I'm going to use this. I know what 0 corresponds to. As long as I know what 0 corresponds to, I'm fine. Okay, it's almost like I'm encoding year and month using these integers, which is fine. Okay, so I'm going to use the indices as my features. So what I'm going to do is data to index. Okay, so this is the feature that I'm going to be using, but I need to turn this into a NumPy array because scikit-learn is expecting from us a NumPy array. Okay, as a feature set. Okay, here is the NumPy array. Now I'm just curious about its shape because remember, scikit-learn is expecting a 2-dimensional input. This is single dimensional. Then I need to reshape this. Okay, let me reshape it and then check the shape. Okay, reshape and then check the shape. So I'm going to reshape this. What I'm going to say is I know that there is a single dimension in here. So I don't care what dimension I have on the other side, but I have at least one dimension here. So now let's check the shape. Now I have 2 dimensions. My data set is a NumPy array of 161 by 1. That is what scikit-learn is expecting from. Okay, you can try. It's not going to work. If you don't reshape your data set, it's not going to work. You're going to have an error. So let me take this and then fit my data. Remember, this is the input. Now I need to put my target variable. What is that? Carbon monoxide, right? Okay, perfect. Now let me see. Yeah. Now I have my linear regression model fit. Perfect. So if you are curious about coefficients of your model, you can always check the coefficients, right? So this is, by the way, if you, so yeah, this is my coefficient. And then if you, what is that? Intercept, right? What is it? Trend model. But intercept. Yeah. So this is my coefficient, and this is my basically my model is 329 plus 0.11 times time, right? So this is my model, which is equal to, let me write equal to in this case, CO2 equals. I'm going to stop in 10 minutes. I know that you guys are tired. I'm going to stop in 10 minutes. We are going to continue, so don't worry about that. Okay, now I'm going to use this model to make a prediction. That prediction, if I mean, you know that, right? So this is a linear line. When I use that prediction, and if I plot that linear line, it's going to be a linear line that is going through these data points. Okay, what I'm going to do is I'm going to subtract that linear line from my data points. That linear line is representing the trend. When I subtract that linear line from the sinusoidal waves going upward, I'm going to be eliminating the trend. And then let's see how it's going to work. Okay, what I'm going to do is I'm going to take my data set. Okay, and let's take the data set. Data CO2. So this is my data set, right? This is my real numbers, right? The ground truth. Okay, and then this is the let's make this say trend model. This is my model. Using my model, I'm going to predict. Okay, using my input. Where is my input? It's right here. NumPy array, and then reshape. This is my input. So let me silence this and then run this. So as you see, these are my predictions for these this NumPy array. So this is my predictions given time. It's a linear line. Actually, on this line, I have my real data points. So that real data points is data CO2 of data, right? So I'm going to subtract. Let me get rid of this PLT plot thingy. I'm going to subtract, and then if you like, when I reshape this is a two-dimensional. So I have 161 I have 161 data points. This reshape is used inside the prediction. So I have 161 predictions. I'm going to subtract this from data CO2, but let's check what data CO2 looks like. I have 161 data points. Now, can I subtract this from this? Let's see. Okay, so these are my residuals. Okay, these are my residuals. Let me turn this into a NumPy array. Okay. So these are residuals. Residual means I subtracted the predictions from real data points. These are the error terms. This is what is left behind after I eliminate the trend. Okay, so eliminating a trend can be done by different ways. This is one of the ways. By the way, this is the simplest case because I know that my data has a linear trend. Sometimes a trend can be non-linear. Then your linear regression model should follow that trend. If you see there is a non-linear trend, then maybe you need to add, in addition to time, you need to add time squared, right, into your model so that you can capture that non-linear trend in your data set. So this is a very simple case. It's a linear line. Okay. So what I'm going to do now is I'm going to call this my residuals. And let me take this to the next line. So, sorry, you can see the code. Okay, so residuals. All right, I got the residuals. Let me get rid of this. Now let me plot the residuals, okay? Let me plot the residuals. And so to do that, let me turn this into a nice, what is it? Panda series so that I can plot it. So let's do this. PD series. Data is index is data2.index. Okay, so this is a Panda series. So I'm going to plot this. I'm going to plot this with color blue. Okay, we are almost done, guys. I know this has been a time. So what happened now is we took this original data set, we removed the trend, and what is left in here is, after that upward trend is eliminated, what is left in here is how our data is changing without the trend with respect to time. So this suggests, just visually, this suggests that there is most likely a seasonality in my data set. What is that? So when it is the same time of the year, I have an increase or decrease at the exact same time of the year. So for example, my peak points are all happening at the same time of the year. Okay, so I need to check all that. And then I need to find a way to eliminate the seasonality too. My goal will be eliminating the trend, the seasonality, and the cycle from my data set so that eventually I'm going to have a white noise, if possible, in my data set. All right, so let me stop here. I'm going to continue, and I'm going to put this file into the folder so that you can yourself work on it, change it, and then we can continue next time. We are going to have our second session next week. You're going to receive an email, and probably this time series workshop may take 4 or 5 sessions. All right, this was just an introduction, a little bit slow. I just wanted to make sure that we understand how we can manipulate data and slowly get into time series. Next time, we are going to talk about autocorrelation, partial autocorrelation, and more about trend, how we can eliminate trend, right? So thank you very much for listening. I'm going to see you guys next week. I'm going to be here for 1 or 2 minutes more, but we are done, okay? I'm going to put this file into the folder. You can work on it later. Thank you. Bye.